Hey, welcome back to Days Post-Apocalyptic World, Season 3. And if you want to find out how we ended up in this awesome schoolhouse building and how we built some of these things, or if you'd like to learn how to survive the zombie apocalypse and kind of put together a food box, we got that too. In this season, we're going to expand our universe. We're going to go up on the roof and check out nebulae and galaxies. And also, right from this tabletop, we're going to build galaxies in the same way that our galaxy originated, using these beakers and heat sources. We're going to create galaxies. And in this episode, we're going to kind of bring all that together and see how it fits into our entropic model of the universe. Right here, starting right now. The entropic model of the universe. Why should we care? How is this fun and interesting? Why is this guy standing on a scaffolding when he could be apparently playing with his dinosaur? And today we're going to explore this model for the first time and see if we can answer some of these questions. So right off the bat, we're seeing galaxies, possibly an explosion, formulas, DNA, humans, planets, and a bunch of dots in the middle. So hopefully this will shed some light into how and why we are here, what is entropy, and if we have time, we'll explore love and relationships. I don't know. So let's start at the beginning of our own universe, about 14 billion years ago, where we had this explosion, this big bang. And 14 billion years in, we've got these trillions of galaxies. And all of that is headed towards the center there. We see these arrows where everything becomes so dissipated, so at equilibrium, from hot to cold, from order to disorder, that everything is so spread out and reacted and done with that even the concept of time is not a thing, because there's no real point to compare any other point in space to where there would be anything going on. But don't worry, that is trillions and trillions of years away, and we are really just at the beginning of this universe of ours at 14 billion years in. But there's a lot of fun and exciting things happening during this time, because as this universe, as this Big Bang processes itself through the universe, we see these swirly things happening that we call galaxies. And we're going to use an analogy of a cup of coffee. When you add cream to it or heat to it, how at the beginning it moves things around in the cup, and ultimately things are all mixed together in the same temperature. But during this mixing phase is where we see all of the magic, and that's where we are. We're currently inside that exciting mixing phase where things are happening. And this formula that we see there, delta S, is entropy over delta T. That's just one of the many formulas a physicist can use to illustrate this concept of, as time goes on, as we go from order to disorder, as we go from heat to cold, dissipation, that the entropy always increases unless something new is added to it. So one of the main purposes of this model is to find universal laws and tendencies that apply not only to galaxies and planets, ourselves, but also to a cup of coffee. So it's important that when we try to find ourselves in the universe, that we're able to live under those laws. So it's called the entropic model of the universe, but in many ways, we tend to put ourselves at the center of the universe. So, and I'm not talking about like before we knew that the Earth wasn't the center of the universe, like we know it revolves around the sun, but in many ways, and we find this in our language, that we tend to relate to the world and to the universe as it applies to humans. So, for example, when we say that something is maybe natural or man-made, and that always stuck with me since I was a kid. What do we mean by that? Are we saying that we're not natural? Are we saying that whatever we are is excluded from the rest of the universe? But when we think about it, no, we know that we're part of nature, but somehow we separate ourselves. So part of the goal of this model is to put a new center to the world and try to remove ourselves from the equation, and hopefully to find truths and laws that apply to everything, not just from us from the inside out. So if we look at this model, it kind of looks like a seashell or a nautilus spiral. So here I've got a very old fossil of an ammonite, and it absolutely amazes me how nature is able to come up with something so perfectly mathematical. And so that inspired me to use this as the base for the illustration of the entropic model of the universe, because what applies to a larger scale has to also apply to a smaller scale. And I thought it was very aesthetic. So as we rotate this model, we see that those ideas of hot to cold, to order to disorder, to high concentration to low concentration, from non-equilibrium to equilibrium, apply in the exact same way. So the galaxy is also swirling itself into ultimate entropy, where it's just nothingness. And that's actually for galaxies and stars, it's I think 5 billion years away. And then there won't be any more galaxies and stars, but the universe is going to continue. But anyway, we continue to rotate our model, and then we have star systems and planetary systems, and those also are being dissipated, and the planets will exist until the star explodes. So currently we are using the sun's photons, and that powers everything in our atmosphere. And as we continue in hundreds of millions of years, then we have chemical reactions that occur, and then DNA, and then small organisms to dinosaurs and to humans. But at each and every scale, everything is being powered by something where it's at non-equilibrium, and then its lifespan goes towards this idea that it will be used up, ultimately dissipated, order to disorder. But then even when something quote unquote dies, there's a whole new ecosystem that emerges from what we would call death, and so it keeps going and going. So one of the main goals of this model is to put things in their proper place and perspective in the universe. For example, so the Big Bang on a large scale creates galaxies. These galaxies create stars. Stars have planets, etc. So it never goes in reverse. You don't have a planet that decides it's going to create a galaxy. Everything emerges from the previous level. So there's a reason for the curvature of those arrows. It's kind of like an umbrella. Everything happens beneath it, but it never goes above it. The other reason for the curvature is something that I learned from Sean Carroll, is that complexity and disorder are not always the same thing. So at the beginning of a system, for example, a cup of coffee, you could have a very ordered system where the cream and the coffee, for example, are separate. And the reason it's very ordered is that randomly it would be difficult to have all of these elements put together, as opposed to when they're completely stirred together. That's called high entropy and most probable, because that's how things would end up most likely if they were randomly laid out. So things start out very simple and low entropy, but also end in high entropy, but also very simple. But at the curvature, at the peak of that curve, is where things are the most complex on their way to the end. And that's where we find the galaxies, planets, and ourselves. Okay, so a few more things, because this is just an introduction to this whole concept. We're going to look more deeply into more specific things. And also I encourage questions and comments. So if you feel like this is total bull or some things don't apply to it, I want to know, because this is still in a actively research phase. And one of the things we notice about this model is that the and beyond part with the dotted lines. So here's the idea, is that we cannot see further currently. Maybe this new Webb telescope will be different, but we can't see beyond the Big Bang, right? So we tend to think that that's the beginning. But according to this model, there was a time when we couldn't see beyond our star or beyond our galaxy. So there's absolutely no reason why this model would not extend to the next thing. So for example, our universe may just be a beaker on a table where somebody is making galaxies. I mean, not literally that, but the idea is that why shouldn't we be part of a bigger whole, and that the explosion this Big Bang, as we call it, is really just another small part of a greater whole. Just like there's trillions of galaxies, and we might have thought at one point that a galaxy was it, that's the biggest thing in the world. Why not have our universe just be one of trillions or more universes somewhere else? In fact, I suggest that that should be the default setting, and the only reason it shouldn't be is that us humans haven't yet been able to look beyond it, which, as we know from history, that's just silly. So that's, according to this model, the default setting is that we are indeed part of a greater whole, and I think that's pretty exciting. So let's go ahead and put humans over here and see how the whole umbrella thing works. So here we still have the planets and the stars. And let's look at what, for example, humans have created, right? So galaxies create stars, and nebulae create stars, and stars create planets. So I think it's important to look at what is human created versus a universal concept. So we'll use words like intelligence or life as things that are like absolutes in the universe. And so I suggest, and according to this model, is that such big terms are actually human interpretations of what we see, and they're still human-centered. So when we say intelligent, what do we really mean? Are we talking about something that's so beautiful and complex that humans created, that it's intelligent? And so if we apply that to entropy, what intelligence actually is that we're putting things together that are optimally dissipative in order to serve our own entropy. In other words, our goal or our purpose in life is to survive and reproduce, and we can see if we look around our space that every single thing that we've put together aids that, it helps it, it somehow contributes to our own survival and reproduction. And hence, according to entropy and this model, it's perfectly natural that we did these things. But it's important to not put these in reverse order. So if we have a definition for life, for example, so we see these single-celled mechanisms in our dinosaurs and the humans, our life, these also belong under that umbrella of humans, and we need to look at it from a bigger perspective. What is life from an entropic point of view? And this reminds me of one of the famous quotes from Michael Russell, who says that the purpose of life is to hydrogenate carbon dioxide into methane. And what that means is that from an entropic point of view, carbon dioxide is low entropy and methane is much higher entropy. So somehow the universe has to figure out how to bridge those, and it takes a complex, what we would call organism, but it's a very complex set of chemical reactions in order to get there, hence life. And so he predicted that there were thermal vents down on the floor even before we found them, where actually life could emerge very early on. And that's kind of what we're looking at here in this entropic model of the universe. What we call life is actually a very complex thing that gets us from low entropy to high entropy. So not the most romantic Shakespearean love story that we would maybe wish for ourselves, but here we're looking for universal truths of why we're here, how we got here. And on that note, so if we look at religion, for example, super entropic, like it is necessary for human cohesion. For when humans first got together, they developed these morals and laws and religions that make that group of humans more successful at survival and reproduction than those who had less of that. And so that group is able to grow bigger and engulf others who either join or don't join, and that group gets stronger and stronger. So if we look at, for example, Greek mythology, according to them, you had all of these gods up in the sky that were human-based. They look like humans, and they're doing all of these things in the world. They even created the universe. So that's where, with this model, we're kind of putting things back in perspective, is that our beliefs, our religions, according to this model, they're not allowed to say that, okay, so like somebody that looked like me created this galaxy, for example. So that's where this is the entropic model and not the human-centered model of the universe. So that'll be about it for this introduction to the entropic model of the universe. In conclusion, entropy is as natural as, say, a ball rolling down a hill, including us. So there's an ultimate purpose and reason why everything exists, even if we can't yet quite put our finger on it. So I'm a big sci-fi fan, right? So space aliens, spaceship, space travel, time travel, all those things are fun and interesting, and they have their place in the entropic world. So for example, when we think of aliens, a lot of times they kind of look like us, and so we don't know exactly how many are out there or life in general, but according to this model, we know that they have some fundamental rules that they would follow, that of entropy, and those would apply to them. And so now our imaginations can now run wild to see what that would look like. So when we think of spaceship shooting lasers at us and being either friendly or hostile, again, those are human types of thoughts and emotions. Maybe they would have the same feelings, maybe not, but we can be sure that it would be an entropic reason, right? A way to further spread whatever it is that they're doing or being, or whatever reactions are happening, are absolute. Whether we put a human personality on it, a matter of opinion, I guess. So thanks for joining me. Please comment, questions, lots more videos and controversies coming your way this year. Do that whole thing with the thing, and we will see you next time on Days Post-Apocalyptic. Where